Hello, good morning. I hope everyone is okay after the storm. So I think I want to get right to it. I want to discuss something that I promised to do today, namely the reports. You probably are wondering what I expect to see in your reports, and I can give you an idea of what that is in a moment. But before I do that, are there any questions? Does anybody have any questions about logistics, if anything, or about the assignment itself, or about information in the manual? Anything? All right, so remember that you understand when these reports are due, right? So their first report is due next meeting, on September 9th. So let me give you an idea of what you should do for these assignments or for these reports. Let me do the attendance first so that I know who is here. Ryan. Ryan Aldis.
Yeah, sorry, here.
Jamil. Buhush. I think you just registered today or something. Or Adil. Christina.
Present.
Thank you. Julian. Thank you. Michael. No, Michael. Jeremy.
I'm here, Professor. I'm sorry. I was here. I didn't hear that you say my name. How are you? Good morning.
Okay, good morning. It's okay.
Yeah, I'm
Michael,
here
right?
too.
Yes.
Okay. Jeremy, you're here, right?
Yes, yes.
You. Edgar. Lopez, Edgar.
I'm here, Professor.
Thank you. Tyler.
Here.
Aresh.
Present.
Jeffrey.
Here.
Thank you. Pooja.
Here.
Thank you. Tan. Sichuan.
Here. Here.
Mustafa.
Here.
Thank you. Adil, one more time. No, Adil. All right. So I have 3 examples of reports that I can show you. These have been submitted to me by by students in previous semesters, so I can give you an idea of what this is. So first of all, I will not be looking into the page number of your report. It could be what I will be looking into is the content. You should really try to explain what you are doing clearly because these are technical ideas. So one of the skills you need to learn as you you know during your career here is that you need to understand or how to you need to be able to convey and explain technical ideas clearly. All right, so this is one way that you can organize your report. You can have a cover page if you wish. You need to have some kind of a short description as to what this assignment is about. These 3 reports seem to do that at the very beginning. This one even has a table of contents. You see, he has an introduction. The other student calls it an objective, right? Or an overview. For example, this one says objective and then an overview, right? You can take some of the words that I have here in the assignment itself, in the assignment number 1. You can take some of these words and paraphrase them, right? You cannot just simply copy my sentences here and just paste them in your report. This is something you should not be doing, all right? But you can take, the ideas of what we're trying to do here for my assignment, or you could take the, since you're deriving some equations for this particular motor that you will be using, you can also reference this link that I gave you, this website from MATLAB for the MathWorks. You can actually reference that if you wish. And let's see here. So overview, and then this has a procedure. So you can organize your report by tasks because usually my assignments will have tasks. So you can, you know, organize it like that as opposed to sections or chapters or anything else. You can have tasks as this person does. And then they explain the setup. They have some figures here. So look at this. You include your figure, which is, this is basically a clipping from the manual. That's okay. But if you're gonna take clippings from the manual, you better have a reference at the bottom, right? You know, you should always, whenever you take something from the manual, you should reference it appropriately. So you see this as a figure number and a caption describing whatever this is supposed to be. It doesn't matter if your figures, whatever they are, they need to have a figure number and a caption. Just a small description of what you're supposed to be doing here. And what is also important, whatever figures you have in this, in your report, you need to reference them. You need to make reference to them from the main text. In other words, you need to discuss whatever figures you put in there. You cannot just expect me to guess whatever you're thinking whenever you're putting these figures in there. So this is what I mean by explaining the technical ideas. So you will be, this is a feedback system. It is a closed loop. It has the amplifier and all these things. I'm just describing what we see here, right? You can give me a short description of what we see here and what this is intended to show, right? But eventually what we really care about is you discussing your MATLAB plots, because these are just general figures of what the setup is, as the student called it here, a setup. This is the system this is actually this is the student, this is the system that he is analyzing. So this is his setup, right? And this is the abstract setup also, but eventually you get to his figures. So look at this, just like we discussed before, you have a label for the axis, right? You have different colors, you have your legends, you have triangle waveforms, right? And then you have a figure number and a legend. And you see from the text, from the description itself, he actually references the figure and he tries to explain whatever this is. What conclusions you can draw from whatever, results you got out of this simulation, what this is intended to show. Because remember, we are trying to study control principles eventually, right? For assignment number 1, you're just deriving some of the equations. And you can just say whatever your figures are supposed to be, because I will be focusing on MATLAB figures, right? This is what we will focus on, at least until we get to the lab. Okay, now you will notice that we will be studying a very specific system, and sometimes I will ask you to plot the same system with different parameters. You're going to be varying certain parameters, and you're going to see how the system behaves when you make these changes to the parameter. So there are many ways that you can incorporate these figures in your reports. One way is you can either plot one figure at a time. So for example, this student is changing the values here from here to here, and then he just shows one figure at a time, and then he discusses one of them as he proceeds to the report. Or you can do it as this other student did it. You can do a multi-plot. So you see, this is a window or a figure from MATLAB that you can actually generate. If you have questions about how to do this, I can show you. But you see, he puts everything, as opposed to having, separate figures here, because if he were to do this separately, he would have 8 separate figures. Instead, he decided to do this multi-plot. In MATLAB, actually, this thing is called a subplot, because the main plot is just this figure, right? So all of these little windows that you see here, these plots are subplots. So you can look into that if you want to do it this way. Another way is you can do what is called a foliation. So if you are varying a single parameter in a system, you can actually foliate the windows here, as I'm going to show you now. So this is a different student. The same thing. The organization is almost the same. They go by tasks, and then they explain what you're supposed to see. But look at these beautiful pictures, right? I mean, it is nice to look at these things because it is clearly organized, and then it shows exactly what it says. Well, let me show you what a foliation is. For example, this one. This is what you call a foliation, because you see we have a particular system, and she's calculating the step response. So this is the blue input, this line here. It goes from 0 to 1. That's the step. And this is the response of the system. And the only thing she's varying is this little gain. that goes from KV 0 all the way up to 10. So eventually when you are asked to do these kind of responses, you can either show them like this or show them like this so that we can actually see the difference between them. Or if you wish to do that, you can actually discuss one figure at a time, but you need to make sure that we can easily see, you know, where these the differences lie when you are discussing this the same system with a different parameter being varied. So this is what we call a foliation. You can imagine that if you had more values, right, from instead of stopping at 10, if you keep increasing, you will see more lines here. So you are basically foliating the space. So this is what a foliation is. You can choose to do that when you are plotting these kind of systems also. So you can keep that in mind, that there are many ways of showing your responses, and I will not be specifically looking for one of them. What I care about is that you explain exactly what I'm supposed to see in the figure, right? Because I know exactly you know, me trying to teach this to you, I know exactly what we're supposed to see. The question is, do you see it? Can you explain it clearly so that the rest of us can see that you actually understand what is being discussed here? So that is your goal. So this, you can see the organizational scheme that this student chose. She has little paragraphs next to the figures. You can do that too. So you see how she varies things, right? She has two separate plots here. She has a foliation here. She has a little paragraph next to this picture, which is okay. Well, you see every figure has a figure number and a caption. This is another foliation. You see, you vary the parameters, and then you see exactly what you're supposed to see as the parameter varies. So that's one way to do it, right? And this is also important for you, because if you are describing a specific system, I think it will be useful for you to describe, or at least show what the setup is, or the system that you are dealing with. So you can go to the report, to the manual, and take the pictures from wherever, you know, chapter we are actually going through. So for example, chapter 1, you may want to take pictures from, I don't know, from the references that you are using to derive the transfer functions, or the ordinary differential equations. You can use those as references. But eventually, when we get to the PID, for example, did I have it here? Which one is the PID? You can see it has a conclusion. Of course, you need to have a conclusion, you know, summarizing your findings or your understanding of the whatever topic you're covering. So this doesn't have a very good picture. So what I want to do is go to chapter 13 and show you. So you see, it doesn't matter how you organize it, as long as it has distinct parts or sections or anything. You can use LaTeX if you feel comfortable with that. You can use any you know, anything that you can, any word processor. You can use Microsoft Word. Doesn't really matter to me. I will be looking for content, not extension, not page numbers, nothing like that. So for example, students also choose, look at this. This is the initial setup for an open loop PID controller. So I think if you are discussing a PID open loop controller, it'll be very helpful if you just take a screenshot of this, or a snippet using the snipping tool. You can just take a picture of this and include it in the report and say, this comes from the manual, and this is referenced in the at the bottom, or something like that. You can take this picture also, but this doesn't really work. So what we can do is this setup here. So this is supposed to convey that this is the main closed loop system, and what you have here controlling everything, this little box here, or this little block, is supposed to be this thing right here. So you see, take advantage of the lab manual when you actually are going through the chapters themselves. Take advantage of this so that you can take these block diagrams and put them in the report, so that you don't have to create these things on your own unless you want to, right? Usually students don't do that. You should just be focusing on the figures so that you can produce the appropriate outputs. I can scroll through this if you want me to, so that you can see what this is, right? Every figure comes with its accompanying discussion. We're excited, this reference list, it has a bunch of references here. This is also something that you should be comfortable doing, right? This is a technical report. Some of these ideas, you know, some of these principles are were taught to you at a different place or by a different source, so you can, you know, cite them. So you see, just choose an appropriate way that works for you to organize your report, but make sure you organize it clearly. You have your figures, you have your captions, you have your titles, and you explain exactly what I'm supposed to see in the response. Okay, so these are the 3 reports. This is why I'm scrolling through these, because I can't really send these to you, right? So are there any questions about the format that I expect to that your report is supposed to have? Who just joined us? Was that Adil?
Yes, Professor, that was me.
Okay, so you can stay with me after so that I can show you what the report is, what we are trying to do here. So I'm just showing,
Okay.
I'm showing everybody what I expect to see from a report. So you can just take a look at this. And so are there any questions about the structure of the report or what we expect to have in the report?
Professor,
Yes, who's
do
this?
you also expect us to submit our MATLAB code with the report too?
Yes, please.
Okay.
Well, you know, whenever you, yes, that's a very good question. So when you're done with an assignment, you're supposed to send me the M file. Do not use this MATLAB function that says publish. This thing is just nonsense. You know, it doesn't really work for, you know, nobody does it like that. I mean, I can see why somebody may use that, but I don't really want to receive MATLAB code using the publish function in MATLAB. So what you should do is just save your file, your M file, your script, and email that to me along with your report. Does that make sense? Who was it that asked the question?
That was me. Thank you.
All right. So you're okay with that now?
Yeah, that's fine.
All right. So everybody, you know, make sure you heard what we just said. You know, you should be emailing me the M file, right? You know, because this is an online class, at least for the very beginning, right? So I want to make sure that, you know, these codes are not identical copies of each other. And they should not be, you know, because if you're working, you know, on your own thing, there is no way that these things can be exactly identical. So that is why I need to receive your codes. So please do that whenever you submit a report. Do not forget to attach your script or your M file. Any questions about the organizational aspects or the structural aspects of a report? Remember, you know, the main thing to take away from this is that you have a lot of freedom in how to organize your image, your responses. You know, just do it in a way that is easily readable and that we can understand what you actually are trying to say for a particular figure. Does anybody want me to scroll through any of these again to see a particular section of a report? You can tell me and I will do that. Are there any other questions about this? Anything, the material that you're supposed to produce for next week? So we are doing this because, you know, you need to understand the system that you are dealing with, right? We're going to be dealing with this servo mechanism. So you should have an idea what kind of equations you'll be dealing with. And this will also help you when you get to the lab, because you will understand that you can actually study this from a more, you know, abstract or theoretical or mathematical way, as opposed to taking data from the equipment. So this is why this is a system that is very well known. So this is why we usually teach these kind of principles with this linear system, or at least the approximations that you make, because you will realize as you are deriving the equations that you actually make a lot of assumptions as you are doing so. So, you know, you need to be aware of what these assumptions are so that you can realize that nothing in real life is a linear system. There's no such thing as a linear system in real life. But by linearizing or by doing some suitable assumptions, we can get it to be, you know, so that it behaves somewhat like a linear system, and then we can study it. Of course, there's a lot of techniques for nonlinear systems, but these are just more advanced and sophisticated. But this is what we are trying to do here for this first assignment. And also another thing, what I usually do after we complete an assignment, I actually run the code on the computer myself, right? So that I can show you exactly what you were supposed to see for that particular assignment. In other words, next time we meet, I will actually be going over a MATLAB code, which is a solution for the particular assignment, which shows the equations of motion. It shows how you should apply these things so that you get an idea of what you should have done, in the previous, in that particular assignment that is due that day. And if you see somehow that, I do things differently, it may be okay. You may be, you may have done the things a little bit differently, but the idea should have been the same. So this is what I will do to help you to actually understand what came before, all the concepts that we have actually discussed up to that week, so that we can move forward and assimilate the other concepts that we need to get to before we get to the full PID controller. All right, so in other words, every time I introduce a new assignment, I will be doing a recap or a summary of what you should have seen for the previous assignment that was due, so that we are up to, on the same page, and so that we understand what we are headed for. All right, so this is what I wanted to do today. Are there any questions? Again, feel free to ask anything. Yes. Yeah. I mean, you should have some kind of explanation as to what you are trying to study or what kind of principles you're supposed to study here. You cannot just put figures in there and explain the figures, right? You have to relate it to something. That is why, you can actually take it like this, right? I mean, so let me give you an idea. You're trying to derive the equations of motion for this motor, right? So what you can do is give me a little picture of the motor, right? I mean, you can either choose the image in the website that I gave you, or take an image from here, right? So what you can do is start from an image, right? And say, we're trying to derive the equations of motion from this, and we do these assumptions, right? So this may help you actually start writing the report, right? So make sure you put in some, sentences here and there, trying to explain the motivation or the drive for actually doing whatever you're trying to do, right? In other words, yeah, some kind of, I mean, but you don't have to go back to the, to your physics textbook and start explaining, Kirchhoff's laws and all these things, right? Just try to do it, as concise as you can, given the material that we are trying to cover, right? So you can do these assumptions and these explain clearly your assumptions in the report. But what I expect students not to do, or what I wish they wouldn't do, is just attach the equations of the motion in the report and say, this is what I got, this is what MATLAB looks like, and this is what you get, right? In other words, as you explain things, depending on how much you write or how much you want to explain, it should come naturally if you base it off the images that you are starting with. And eventually you will have concrete block diagrams to start with. So that will be a nice starting point for you to describe exactly what you're getting into for the particular report that you are writing. Do you see what I mean? All right, so I do not have a page, a minimum page number, because I don't want to give you any additional constraints. But if you submit a one-page report for this, you cannot expect to get a full credit. I cannot, there's no way you can fit all these reports into a one-page report, right? I mean, that would be asinine. I mean, this is for everyone, right? This is. Oh yes, I will try to do that before you actually submit the next one. That's a very good question. So what I do is I read them, I read through your reports clearly, and I write comments and suggestions and critiques for your specific report. So I will read through all of your reports clearly to see where you are going. And if something is missing, I will try to point this out to you. And I will do that. I will try to get that to you by before next time we meet, so that you can make the appropriate updates for your next report. Does that make sense? Yes, because the assignment, you see, according to this, we have a report due next week, and then we have a report due the meeting after that, which is actually a week, 2 weeks after this one, right? So in other words, we're not meeting in a week in September for some reason. I don't have it here, right? But I usually read your reports, the day or the day after they are submitted, so that you can have some feedback and that you can incorporate these criticisms into your next report. Okay, so yes, you will receive feedback from me on your individual report. All right, you will have you'll see. All right, so you should expect that from me, and if you don't get it, then you should be contacting me. Maybe there's a problem with the email or something, but you should expect some email from me, some individual email from me at some point before the next assignment is due. All right. All right. Anybody else? These are good questions, right? I mean, these are things. These are good things because it helps you. It helps us, get our bearings on the class and how we're gonna be working throughout. Any other questions, please? Anything? All right. So next week or next time we meet, make sure you keep track of the assignment calendar. We'll actually go into some feedback principles and ideas so that we can start simulating these things now that we have the equations of motion. All right, because now that we have a system to study, now we can close the loop around it and see what we can get when we, play around with the gains and stuff, right? So that's where we headed, and that's what we will be doing next week. So if you don't have any questions, you can log off now. I think I will stay with the person that came in late to explain to him what we just talked about for the first 15 minutes. So if you're okay with the material and if you are clear what you are supposed to do for next week, you can just log off and I will see you next time. All right, Adil, are you there?
Thank you, Professor. Have a good day.
Yes,
All right,
I'm here.
You too. All right. I don't think you got a chance to see the report, did you?
Not fully.
First of all, do you have any questions about what you're supposed to, what the assignment itself is about and what you're supposed to produce for next week? Any questions about this?
So I can summarize what I know. I know we are supposed to drive the equation for the motion for the motor. How does the motor behave? Like it'll be a function of voltages and the revolution per the speed of the motor and other equations that are assigned in the first assignment. And then we have a MATLAB code where we will give different types of functions like step function, sine wave, and all those other functions, and see how the system behaves.
Yes.
So this is what we are supposed to do.
Yes. So the derivation of the equations or the ODEs, the ordinary differential equations, they should not be something very complicated. All right. You're not going to go there and, read books about how to actually model motors, right? I gave you a nice reference, a website where they actually derive the equation. So you can actually do something like that, right? Try to explain or explicitly state all the assumptions that you make as you derive the equations, right? But you should not really, be giving me a theoretical conference about the motor, right? I mean, it's not like that. You see what I'm saying here?
Yes, yes.
All right, so yes, and then once you get the equations of motion, if you remember from last time, I think you were here, right? Last time? Yes. So
Yes,
remember last time I gave you a tutorial into MATLAB, a short crash course where I showed you how to use the step commands, how to produce nice looking plots, how to use these LSIM, how to adjust your time vector so that you can actually understand what it is you're getting when you are plotting these kind of responses. So you're supposed to take that code that I gave you and extend it in the sense that you will introduce the new equations that you derived, and you will obtain the responses, the appropriate responses according to the assignment. Because if you remember last time, we derived the step responses and the square wave response and the triangle wave response for a particular low pass and high pass filters, if you remember. So all you have to do is just replace those with the ones that you obtain and try to see whether you can generate the responses and whether you can try to explain what you are seeing. Does that make sense?
Yeah.
And now
Completely.
for the report, I don't know how much you saw, but this is what a report is supposed to look like. You know, this report is 27 pages long. I will not be looking at a page number, like I said, but you have to have a certain structure. You can have a table of contents if you wish. You have to have sections or tasks or, divisions in your report clearly, marked so that we understand where we are and what we're trying to do. You have to have figures, and they have to have figure numbers and captions. And whenever you are talking about, or in the body of the report, you must reference your figures so that you can explain to the reader what you're supposed to see, or what you are trying to derive from what conclusions you can draw from whatever you are showing. You cannot just give me a figure and then never talk about it in the report, right? Otherwise, why is it there if you don't need to talk about it, right? So all of these things
Yeah.
are usually things that you should have things that you have been asked to do in previous courses where you write reports, the usual stuff, right? You can use any kind of format that you want. You can use the double column IEEE. You can have latex styling. You can have anything you want to have. But what I care about is the structure where you have nice presentable figures and you are referring to the figures from the text so that we can see your thinking, so that I can understand what you are trying to say about the figure and what conclusions you are drawing from the figure. Another thing, I don't know if you saw that there are many ways of plotting your responses when you vary gains. So for example, this student chose to compute the response for a particular value, as a parameter as it is varied, and he chose to show this one figure at a time, as you see here. Or this other student, of course, if you do this, it's going to take more pages, right? But that doesn't matter. Remember, there's no page limit or a minimum number. What I care is about content. So you can do one figure at a time, or you can do what this other student did. You see, he has
So you're gonna have all the figures in one place in
Yeah.
MATLAB. Yeah, like this.
But you see, if you're gonna do this, make sure it doesn't become too crowded, right? I mean, it doesn't become, too hard to see. Or you can do foliations. This will apply when we are actually varying the single parameter, because if you see this figure, these responses have nothing to do with each other, right? Because this is a triangle wave. This is the apple for the low pass filter and the high pass filter, right? So you cannot really put these inside the same figure or the same plot. However, when you are varying a system and you are only varying a single parameter, you can have something like looks like this. So what we have here is the
Yeah.
same system, but the only thing that varies is a particular parameter. It goes from 0 to 10, and now you can see the different responses for a particular gain. So this is what we call a foliation. You can do this, you look one of them or something like this. Do you see what I'm saying here?
Yeah, this looks, a variation one looks really good. What does it call? I'm gonna look into that command. I'm not familiar with this command only. The other two commands I'm familiar with.
So what you can do is just use the regular plot, but you have to look into the hold on, hold off structure. So let me show you. I can show you that.
Mhm.
I have a. It's very easy. It isn't even a command.
Oh yeah, it's a hold on to the figure and
Yeah,
then
because
plot the other.
if you use the plot command, for example, if you use it the first time, and then if you have another plot command right after that, it will eliminate the first plot and it will just plot whatever was, the latest plot command. So you may get confused as to why is it only plotting the last command. It is because it didn't hold on to the previous plot. So whenever you are doing a foliation, you can do the hold on command so that it shows you all of the plot, so that it plots all of the figures that you're trying to show here. You see what I'm saying?
Yeah, I know how to do this. I know.
Yeah, so
In
it's very,
MATLAB, MATLAB I have done research with. I know MATLAB a little bit.
okay, very good. But
Yeah,
in any
yeah.
case, if you have any questions, do not hesitate to email me, all right?
Yeah, sure.
Of course, try not to do it, 2 hours before the report is due or the night before, because then, it doesn't really make much sense to ask that, right? So allow yourself enough time to see where you are and to see if you may run into some potential problems. Does that make sense?
Yeah, definitely. I will start working on the report earlier and ask you questions before, way before it's due time.
Do you have any questions about the organizational aspects of this, the structure? Are you clear on what I expect to see?
Yes, I think I am clear on what kind of reports you want. They have to be very clear and numbered with the, if possible, with the title pages. I mean those content pages. So as long as
this is standard stuff, right? I mean, usually
Yeah,
every kind of report that you submit should have something like that, right? So you see,
yes,
it's only standard stuff that I'm asking for, right? Nothing complicated, nothing fancy. I will be interested in the content of your reports, not, whether, you have a nice fancy margin or you have a nice fancy something, right?
yes,
Oh, yeah.
yes. It's pretty
So,
standard.
Anyway, does that make sense? Are you clear? Are you you're set on what you're supposed to do for next week?
Yeah, I just realized some of the reports that you showed have page numbers, some don't. Do you prefer
Yes.
to have page numbers or no?
Yes. For some reason, this one neglected to put page numbers, but that is something I should have said on the before everyone else left, is that you need to have page numbers. Anyway, if there are missing page numbers because it is the first report, I will make sure to put it, as a guideline or as a feedback bullet point in my after I have read the report. But for now, since you are asking, make sure to put a page number. But if for some reason somebody neglects to put a page numbers on the report, I will make sure to let them know before they submit the next one, so there are no problems, right? Page numbers are
Okay.
easy for me because if I have to say something, for example, about your descriptions here, right? Instead of me saying, oh, below figure 7, or if there's no figure here, assume this page is just full of text, right? And there's no figure here. But I want to say something about whatever, so something you wrote here. It is much easier for me to just say which page number I'm talking about so that we can know what so that you can know exactly what I'm referring to, right? Without page numbers and with all, any other landmarks, inside the report, then I cannot really give concrete, focused feedback. So yes, you should try to include page numbers. Make sure you do that. Anyway, whatever is missing, whatever, so people neglect to do, I will make sure to write my comments accordingly so that they can incorporate it in the next report. All right.
All right.
All right. Anybody else? So I see I still have some people with me here. Are there any questions? Does anybody want to meet with me in a more individual meeting or private meeting? Today. Okay. So any questions? All right. So this is what we're trying to do. This will eventually, we will eventually get to studying the feedback principles, but we have to start somewhere so that we know where we are and so that we have something concrete to work against or to work with. All right. So if there are no more questions, I think I will see you next time.
Okay. Thank you. Have a good day, Professor.
All right. Bye-bye.
Bye.
Bye.